Today, we will answer this geometry challenge coming from one of our followers. And the question goes like this. The goal is to find the area of the shaded region, given this information. This length measures 5 units. This is 5 units. This is 4 units. The whole side of this triangle is 13 units. This is 1 unit. This is 8 units. And this is 6 units. And the goal is to find the area of the shaded region. So pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer, the area of the shaded region simply equal to 44 square units, and that's the answer to this question. And the question, of course, is what is the solution to find the area of this shaded region. And in this video, I will show you 2 different approach to answer this question. In our first method, we will use the concept of sine and the concept of cosine law. The second method we will use is just the ratio of areas. So let's begin with our first solution using sine and cosine law. In this solution, we need to make this angle right over here be equal to theta. This is very important in our solution, because what we need is to use the cosine law to find the cosine of this theta. Then after that, we will use the concept of sine to find the area of some triangles, and from this, we can now find the area of the shaded region. Now let's begin. Let's find the cosine of this angle theta. Using this big triangle, we know this angle theta. This side is 13. This side must be equal to 5 plus 5 plus 4, or simply equal to 14. And the bottom part, which is 6 plus 8 plus 1, or simply equal to 15. Using cosine law, we have 13 squared equals 14 squared plus 15 squared minus 2 times 14 times 15 times cosine of theta. Simplify. This will give us 169 equals 421 minus 420 times cosine of theta. We want cosine of theta, so simplify this. Then divide both sides by 420. Simplify, and we get that cosine theta equals 3 over 5. Now let's set aside this result. From here, we are now ready to use the area of the triangle using sine function. Take note, we need the value of sine theta. Since we have cosine theta, we know sine theta simply equal to square root of 1 minus cosine squared theta. We know cosine squared 3 over 5. Substitute to the cosine theta, and sure enough, we get that sine theta simply equal to 4 over 5. And from here, what we're going to do is to find the area of this triangle having an angle of theta and the side length of 10 and 14. Then, to find the area of this shaded region, what we're going to do is to subtract the area of this triangle having an angle of theta with the side length of 5 and 6 units. So let's do that. First, we need to find the area of this triangle with an angle of theta, side length of 10 and 14. So we have 1/2 times 10 times 14 times sine theta. Then subtract the area of this triangle. We have 1/2 times 5 times 6 times sine of theta. Simplify. This will give us 70 times sine theta minus 15 sine of theta. 70 minus 15, this will give us 55 sine theta. And we know the value of sine theta. This is just 4 over 5. Now, 55 times 4 over 5, this will give us an answer of 44, which is the area of this shaded region. And that is our answer to this question. So, using the concept of sine and the cosine law. Now, how about the second solution using the ratio of areas? So let's begin. Using ratio of areas, it tells us that if we have 2 triangles having the same height, then the ratio of their areas must be equal to the ratio of their bases. In order to use this concept, we need to insert 2 segments like this. Now focus on these 2 triangles. For sure, we have the same height. Therefore, the ratio of their areas must be the same as the ratio of their bases. let the area of this yellow triangle be equal to x. Therefore, this green triangle must be equal to 8x. Now, how about these two triangles? We know for sure they have the same height. Therefore, the ratio of their areas must be equal to the ratio of their bases. If this is 8x, then this triangle, this yellow triangle, must be equal to 6x. But if we're looking on this direction, we have two triangles with the same height with the same base. In short, they have the same area. In short, we can split this 6x into 3x and 3x like this. Finally, let's look at these two triangles. So with the base of 10 and the base of 4, obviously they have the same height. And the area of this yellow triangle must be equal to 3 plus 3 plus 8 plus 1, or simply equal to 15x. From 10 becomes 15, so 10 times 3 over 2. In short, the area of this green triangle must be equal to 4 times 3 over 2, or simply equal to 6x. From here, we can now get the shaded region. The shaded region in this triangle simply equal to 3x plus 8x all over the sum of those areas, 3x, 3x, 8x, x, and 6x. Simplify, this becomes 11x over 21x. Simplify, this is just 11 over 21, or simply 11 over 21 of the area of the whole triangle. So the shaded region simply equal to 11 over 21 of the area of our triangle. And the question is, how do we get the area of the whole triangle? We will use what we call the generalized Heron's formula. And we have the formula 1 over 4 times the square root of 4 times a squared times b squared minus quantity a squared plus b squared minus c squared quantity raised to the power of 2. I have a proof of this formula, and I will put the link on the description of this video. Now, in order to use this, we need to have the side length of our triangle. So we know this side must be equal to pi plus 4, and on the bottom part, we know this is just 6 plus 8 plus 1. Pi plus 4, this will give us 14, and 6 plus 8 plus 1, this will give us 15. And we can set that A equals 13, B equals 14, and C equals 15. And no matter which A, which B, or which C, this formula works for all triangle. So for now, A equals 13, B is 14, and C equals 15. Simplify. This will give us 1 over 4 multiplied by 336. And 1/4 of 336, this is just 84. In short, the area of this triangle with the side length 13, 14, 15 is 84 square units. So the shaded region simply equal to 11 over 21 of 84, which is equal to 44 square units. And that is our answer to this question. Therefore, given this figure, then the area of this shaded region simply equal to 44 square units. And as always, we are done.